Greetings, my dear students. Today we're going to learn how to simplify a rational expression. So, all the expressions that you have here, they are called rational expressions because they look like a fraction. Okay? Before we do that, be sure to remember the 7 cases of factor that I put here. This is very important and it's something that we saw the last class. So let's start with the first exercise. X squared plus 4x minus 12 over 3x minus 6. So first I'm going to write x squared plus 4x minus 12. This is a quadratic trinomial. And how do you factor this? You split the first term into x and x. You split this last term, which is negative 12. And if you multiply in cross, you're going to have 6x minus 2x, which is 4x, which is also the term in the middle. Therefore, the factor of this trinomial is going to be x minus 2, x plus 6. If you pay attention to the denominator, we have 3x minus 6. This case is called greatest common factor. The greatest common factor is going to be a number that 3 and 6 can be divided by. That number is going to be 3 itself. And inside the parentheses, you put x minus 2. Okay? Now, if you plug in back in the original rational expression, this is going to be x minus 2 times x plus 6 over 3 times x minus 2. Since you have a parenthesis on top that is also repeated at the bottom, they cancel each other, and your final answer is going to be x plus 6 over 3. You don't have to put parentheses, but if you put, it's going to be also fine. Okay? Feel free to pause the video so you can continue by yourself and then double check your answer. The next rational fraction is going to be x squared. X squared minus 4x plus 3 all over x squared plus 3x minus 4. So the one on top is again a quadratic trinomial. Remember, it's called quadratic trinomial because it has 3 terms. That's why it's trinomial, and quadratic because the maximum exponent of the x is square or power of 2. So how do you factor this quadratic trinomial? You split the first term into x and x. You split the last term into negative 3 and negative 1. And then you multiply in cross. This is going to be negative 1x. This is going to be negative 3x. And the answer of this part is going to be negative 4x, which is the one in the middle. So we did correctly. This is x minus 3, x minus 1. Let's see, the denominator is going to be x squared plus 3x minus 4. Now, again, we split the first term, x and x. We split the last term, which is negative 4, negative 1, and positive 4. And this becomes 4x minus x. The answer is going to be 3x, which is the one in the middle, so we did it correctly. The answer is going to be x minus 1, x plus 4. If we plug in the original equation, in the original expression, is going to be on top x minus 3, x minus 1, and at the bottom is going to be x minus 1, x plus 4. You cancel x minus 1 with x minus 1, and the final answer is going to be x minus 3 over x plus 4. Let's continue with the next exercise. The next rational expression is going to be 4x plus 12 over x squared minus 3x minus 18. So we're going to write the first expression on top. This is going to be very easy. It's going to be greatest common factor. So we factor a number that 4 and 12 can be divided by at the same time. Is going to be 4. And inside is going to be x plus 3. If you write the expression at the bottom, that's going to be a quadratic trinomial, and you split the first term x and x, and you split the last term negative 6 and positive 3. So if you multiply and cross, this is going to be 3x, and this is going to be minus 6x. 3x minus 6x is negative 3x, which is the one in the middle, so we did it correctly. The answer is going to be x minus 6, x plus 3. We plug in the original expression, and we have on top 4 times x plus 3 all over x minus 6, x plus 3. If you cancel what you have on top and also at the bottom, you're going to have the final answer, which is 4 over x minus 6. Let's continue with the next rational expressions. We have x squared plus 11x plus 24. And at the bottom, we have 5x plus 40. So the first expression on top is definitely a quadratic trinomial case. So we split the first term into x and x, and the last term into 8 and 3, positive both. If you multiply and cross, this is 3x, and this is 8x. If you add them both, you're going to have 11x. Therefore, which is the one in the middle. Therefore, the factors are going to be x plus 8 and x plus 3. Now, if you pay attention to the expression at the bottom, we have 5x plus 40. This case is called the greatest common factor. You look for a number that 5 and 40 can be divided by. So we factor out the number 5, and inside I'm going to put x plus 8. If we plug in the original expression, this is going to be x plus 8, x plus 3, and at the bottom you have 5 times x plus 8. What do you have on top that also is repeated at the bottom? X plus 8. So you cancel those. And the final answer is going to be x plus 3 over 5. Let's continue with the next rational expression, which is x squared minus x minus 12 all over 2x squared minus 9x plus 4. So I'm going to rewrite the quadratic trinomial on top, and we factor. We split the first term, which is x and x, and we split the second term, which is negative 4 and positive 3. If you multiply and cross, this is going to be 3x minus 4x, which is negative x. So the factors are going to be x negative 4 and x plus 3. Let's see the quadratic trinomial at the bottom. It is 2x squared minus 9x plus 4. So we're going to split the first term again, 2x and x, and then the last term, which is 4, I'm going to split it into negative 1 and negative 4. So if you multiply and cross, this is going to be negative 8x, and this is going to be negative x. So the answer is negative 9x, which is the one in the middle. So if we plug in back in the original expression, this is going to be x minus 4, x plus 3, and at the bottom is going to be 2x minus 1, x minus 4. You cancel x minus 4, and the final answer is going to be x plus 3 over 2x minus 1. The next expression is going to be x squared minus 1 squared all over 2x squared plus 5x plus 3. If you pay attention to the expression on top, the case is going to be the difference of two squares. Difference because you have subtraction, and squares because you have power of 2. So if you want to factor this, you put two parentheses, and then you write x plus 1, x minus 1. The one at the bottom is definitely a quadratic trinomial. So how do you factor this? You split the first term, 2x and x, and you split the last term, 3 and 1. 2x times 1 is going to be 2x, and x times 3 is going to be 3x. If you add them both, it's going to be 5x. So the factors are going to be x plus 1 to x plus 3. If you plug in the original expression, x plus 1, x minus 1 over x plus 1 to x plus 3, you can cancel x plus 1, and the final answer is going to be x minus 1 over 2x plus 3. Let's continue with the next expression. We have 3x squared. Hold on a second. Yes, 3x squared minus x minus 2 all over x squared plus 4x minus 5. So let's see, the one on top is definitely a quadratic trinomial. You know that you have to split the first term, which is going to be 3x and x, and then you have to split the last term, which is 2 and 1. So this is going to be negative, this is going to be positive, and if you multiply this is going to be negative 3x, and this is going to be 2x. So the answer is going to be negative x. Maybe you're asking yourself, how do I know what numbers and what signs to choose? It's just a matter of practice. When you practice a lot, the numbers come to your mind immediately. Okay, so the factors in here is going to be 3x plus 2 and x minus 1. Now let's see the expression at the bottom. It's also a quadratic trinomial, so we split the first term, x and x, and we split the last term, which is negative 1 and positive 5. So x times 5 is going to be 5x, and x times negative 1 is going to be negative x. 5x minus x is going to be 4x, which is the one in the middle. So definitely the factors are going to be x minus 1, x plus 5. If we plug this back in the original expression, this is going to be 3x plus 2 times x minus 1 all over x minus 1, x plus 5. And the expression in common, x minus 1, cancels to the other expression, x minus 1. The final answer is going to be 3x plus 2 over x plus 5. Let's continue with the last exercise, which is 3x plus 3 over x squared plus 3x plus 2. So the expression on top, 3x plus 3, is very easy to factor. It's the greatest common factor. Between 3 and 3, what is the number both can be divided by? And the answer is 3 itself. And inside the parentheses, I'm going to put x plus 1. If you factor a quadratic trinomial like x squared plus 3x plus 2, you have to split the first term, x and x. You have to split the last term, which is 2 and 1, and then multiply and cross. And 1x plus 2x is going to be 3x, which is the one in the middle. If we plug in the original expression, this becomes 3 times x plus 1 over x plus 2, x plus 1. You have in common x plus 1, so you can cancel each other, and the final answer is going to be 3 over x plus 2. That's it for all these exercises called expressions, rational expressions. Now, if you want to type a fraction in Google Docs, like 3 over x minus 6, this is not the proper way to do it, please. Okay? We're going to learn how to do this fraction thing. So the first thing that you have to do is click in the option view, that is right here, and then go to the option show equation toolbar. Now you have a new bar here at the bottom of all the bars, and the first option is called new equation. You count 1, 2, 3, and 4. In the fourth option, you're gonna click and see the option A over B. If you click on A over B, you're gonna have a fraction like, so you can type, for example, 3 on top. And if you click at the bottom, you can type, for example, x minus 6. This is the proper way to express a fraction. Now we're gonna see how to round a number. And we have 3 cases. Case 1 is going to be called nearest whole number, also called 0 decimals. Nearest tenth or 1 decimal. And finally, nearest hundredth or 2 decimals. So, for example, if you have the number 3.498, they are asking you to find the nearest whole number or 0 decimals. So you have to check one more decimal. If you check the first decimal is going to be 4. 4, you have to check if it's greater or equal to 5, is going to increase the digit. But if it's less than 5, it's going to stay as it is. Stays. So the number 4 is greater equal to 5 or is less than 5? Of course it's less than 5, therefore the number 3 is going to stay. The answer of this is going to be 3. Okay? Pay attention that this symbol is called approximately. Let's see another exercise, another case. When you have, for example, 5.621. So again, we need to round to the nearest whole number. There we have to check the first digit after. So the first digit is going to be the number 6. Is the number 6 greater or equal to 5 or less than 5? It's definitely greater or equal to 5. Therefore, it's going to increase this digit. So the 5 becomes 6. Okay? Let's see the other cases for the nearest tenth. Okay, now we have to find one decimal. If you want to check for one decimal, you have to check the decimal that goes after. So in this case, we're gonna check for this and for this. The number 2 first. The number 2 is greater equal to 5 or is less than 5? Is definitely less than 5. Therefore, the number 5 is going to stay or is going to increase. In this case, is going to stay. So the answer for this is going to be 4.5. Now, if you pay attention for the next number, we check for the number 8 because it's the second decimal. The second decimal 8 is greater equal to 5 or less than 5. Is greater equal to 5. Therefore, it's going to increase, but it's going to increase this number. So this is going to be close to 10.4. And that's going to be it. And finally, we're going to do two exercises for the nearest hundredth. For example, okay, this time they're asking you to have two decimals at the end. Since we have two decimals at the end, we need to have to check the third decimal. The third decimal in this case is the 1, and in this case is 8. If the third decimal 1 is greater or equal to 5, it's going to increase the previous decimal. But if it's less than 5, it's going to stay. So number 1 is less than 5, so it's going to stay. This is going to be approximately 2.54. Now, the third decimal is number 8. The number 8 is greater or equal to 5 or less than 5. It is greater or equal to 5. Therefore, it's going to increase the previous decimal, which is 3. So this is going to be approximately 12.44. That's all for how to round a number. Now we're going to see conversion problems. Conversion problems. So for mass, we have the measurement in kilograms, also grams, also milligrams, and also micrograms. And for volume or liquids, we have liters or milliliters. So if you want to convert from left to right, you have to multiply times 1000. For example, from kilogram to gram is times 1000. From grams to milligrams times 1000. From milligrams to micrograms times 1000. And finally, from liters to milliliters is going to be also times 1000. Okay? For example, let's see a regular example. 3.2 kilograms to grams. So we multiply 3.2 times 1000. The answer is going to be 3,200 grams. Okay? Also, instead of multiplying times 1000, you can move the decimal point 3 places to the right. Okay? For example, 3.2, we're gonna convert to grams, so we're gonna move the decimal point 3 places to the right. So we move 1, 2, and 3. And we filled the blanks with zeros. So the answer is also 3,200 grams, which is the same, of course. Okay, let's do another exercise. For example, 4 liters to milliliters. You multiply 4 times 1000 and the answer is 4000 milliliters. If you want, you can start with the 4. The decimal point that is not seen is here at the end. So you move 1, 2, 3, and then you fill out the blanks with zeros, and this is gonna become 4000 again. Okay, that's how you do the conversion problems from left to right. Now we're gonna see from right to left. When you want to convert from right to left, it's gonna change just a little bit. So it's gonna be from grams to kilograms, or from milligrams to grams, or from micrograms to milligrams, or from milliliters to liters. This time you don't multiply, but you divide by 1000. And you move the decimal. Another option is to move the decimal point 3 places to the left. Okay, so let's see an example. Let's suppose you have 4,251 grams and you want to convert to kilograms. So you have to divide by 1000. 4,251 by 1000 is going to be 4.251. This is approximately, if you put just one decimal, approximately 4.3 kilograms. Okay? Usually when you have an exercise or a problem, it's going to tell you how many decimals you have to round it. Let's do another with liters and milliliters. You have 3,549 milliliters and you have to convert to liters. This time we're going to use the decimal point. So we start moving the decimal point from right to left. 1, 2, 3. The answer is 3.549, which is approximately 3.5 liters if you round to one single decimal. As you can see, if you need to multiply times 1000 is when you go from left to right, and if you want to go from right to left, you're going to divide by 1000. This is going to work just when you are working with kilograms, grams, milligrams, and micrograms, or liters and milliliters. But if you are converting from kilograms to pounds, for example, it's going to be a little bit different. Let's see an example. You have to remember that 1 kilogram is equal to 2.2 pounds. Okay? So we have two situations. Convert 20 kilograms to pounds, and the other one is convert 85 pounds to kilograms. So if you want to convert from kilograms to pounds, you have to do a proportion. You say 1 kilogram is equal to 2.2 pounds. Pay attention that I didn't put equal, but a fraction. I put a fraction actually, but that's the way this is done. And then the other information that you have is 20 kilograms. This 20 kilograms is going to be on top since we have also kilograms here. Okay? So we put the 20 kilograms here. And since we don't know how many pounds it's going to be, we call it X. And now we multiply in cross. 1 times x is going to be x, and then we multiply 20 times 2.2, and that's going to be 44 pounds. If you want, you can remember from kilos to pounds, multiply times 2.2. Now, we're going to see the other situation when we need to convert from pounds to kilograms. Again, we have to say 1 kilogram is equals to 2.2 pounds. Now, the information that we have is 85 pounds, so we have to put it at the bottom. And on top, we're going to put x because we don't know how many kilos is going to be that. Now, x, 2.2x is going to be equals to 85, and x is going to be equals to 85 divided by 2.2. We're going to use the calculator for that. 85 divided by 2.2, and that's 38.6. So again, if you want to remember from pounds to kilograms, you divide by 2.2. From kilograms to pounds, you multiply times 2.2.